Hey students, this is Mrs. Tran-Bloom. Now this is section 3.3, features of the functions, okay? Now there's a lot of vocabulary, so what you might want to do is press pause and then write down the definition as we go along, okay? 3.3 says, analyzing a graph means looking at and describing the characteristics with numbers or number phrases. We describe these as key characteristics with mathematical notation or math language. Definition number 1, vertex. Usually we use it on a parabola or an absolute value function. So a parabola either opens upward or downward. Now, an absolute value function, which you will study later, is going to be a V that's going to open upward or a V that can open downward like a parabola, but it's not a U shape, it is a V shape. Now the vertex is either the highest or the lowest point on the graph, and where the parabola or the absolute value function crosses its axis of symmetry, okay? So now the second definition is axis of symmetry. What is an axis of symmetry? Now in a parabola, an axis of symmetry is going to be a line that cuts it directly in half. So that means the left and the right will be exactly the same. Similarly to if we were to have an upside down parabola. It's going to be a line, so that means it will be an equation, okay? If we were to have an absolute value function, there's a line that also bisects it directly in the middle. So that means the left and the right would be exactly the same. So axis of symmetry is a line that divides the graph into two equal parts or two halves. Rate of change is very fancy for the word slope, okay? It is a constant number describing the change in y divided by the change in x. As you guys know already, the change in y is y2 minus y1 and divided by x2 minus x1. That's why y2 minus 1 is called the change in y. x2 minus x1 is the change in x. So again, rate of change is very fancy for the word slope. Now, only a linear and an absolute value function would have the rate of change. X-intercept is the point, or sometimes later we will study functions that would have multiple x-intercepts where the graph crosses the x-axis. Y-intercept is the point or points where the graph crosses the y-axis. We study a little bit about the domain. The domain is a set of all possible inputs. Inputs is the same as x values, okay, for the graph. Range is a set of all possible outputs, and outputs is the same for all y values. Function is a relation, usually a graph or an equation where each x input has exactly one output. So what that means, guys, so let me give you some example. A parabola would be a function, okay? Because what that means is, hey, whatever, let me just kind of make this, whatever x we plug in, so let's say when x is 1 or x is 2, you would get one y value for each x that we plug in. Now, if you guys remember, it also passes the vertical line test. A vertical line test meaning that if we draw a vertical line, that means up and down, on the graph itself, it only intersects 1 and 1 point only. Now, what would not be a function? If I were to give you a sideways parabola like this, okay? So this right here, it's not a function because each input, so let's say I'm going to pick like this value of x, has that and that for y, because that x value location has a y up here, let's call it y1, and a y down here. So this is not a function. And again, if we were to use the vertical line test, students, if we were to draw a vertical line test, can you see that it's crossing over that green sideways parabola twice? So that's why it's not a function, okay? So a function would be a parabola. It can be upside down or right side up, a V-shaped graph, so that's an absolute value graph, and then even a cubic graph, okay, like this. Anything that, if we were to make a vertical line test, it would only cross over one time, okay? So any vertical line test that we graph, it can only intersect it one time. One-to-one, it's even more special than the function itself. So to be a one-to-one, so this is really unique. To be a one-to-one, first you have to pass this function test, okay? So it's a function, but not only that it's a function, it has, not only that every input has an output, but every output can only have an input. So we talked about a parabola being a function. It is not a one-to-one. And here's the reason why it's not a one-to-one. So let me make a coordinate plane. It's not a one-to-one because if we were to plug in a y value, let's say somewhere here, okay, it has two x values. Whoa. So that means it's not going to be a one-to-one. It's a function. It's just not a one-to-one function. So if we were to give you a graph, a one-to-one means if we were to draw a horizontal line test. Okay, so horizontal line test must pass. So that means if we were to make a horizontal line test on the graph, it can only pass, or it can only intersect the graph once. But again, it has to pass the function first. So a function, if we were to make a vertical line test, it has to pass the vertical line test, okay? So must pass vertical line test, or vertical line test must pass first. So that's what it needs to be a function. And a horizontal line test, in addition to being a function of one-to-one, also need to pass the horizontal line test. Maximum, this is a very simple definition, students, is where the function or your graph reaches its highest point. So on a parabola or on the absolute value, it might be the vertex. Now the reason I said might be is because, so if we have an upside down parabola, so this would be a maximum, okay? But if we have a right side up parabola, then that would be a minimum, which is the next definition. A minimum is where we have the lowest point, okay? So again, for a V-shaped graph, it can be a vertex, depending on if it's upside down or right side up, okay? X intervals where the function is increasing. So this is really new to us, students. So I want you to pay attention to these last two definitions, okay? In the simplest definition, we are always going to write the intervals, the X intervals for increase and decrease both, okay? Increase and decrease from the smallest x, comma, larger x, okay? Now, how do we know it's increasing? Increasing is when y goes up, but we write the answer using x value. So I know this is always the most difficult definition of all. In decreasing, we still write it the same way. Smallest x value, comma, larger x value. But we know it's decreasing where y goes downward. So for example, let me just give you a quick graph of this parabola. Let's just say, here we go. And let's make that vertex at, let's say 2. Okay, students? So as you can see, on the right side, y goes up. It goes up until this very, very high point called the maximum point. Well, that's increasing. So on this side, it's increasing. And how do we write that increasing interval? It's some x value over here, comma, some x value over here. Well, the x ends right here. So 2 is where it stops increasing because that's the max. It can't go any higher than the max. Now, where does this end over here? Kind of like the domain. The negative, sorry, this arrow right here means it goes towards negative infinity. So it increasing from negative infinity all the way to 2, and that's the x value. Now decreasing is when y goes down. Can you guys see that? Hey, every time, think about it, we take a step to the right, y is getting less and less and less. So the right side is decreasing because y is getting lower and lower and lower. But when we write the answer, it's called an interval. I mean, it's some smaller x, comma, larger x, okay? So when we write it, okay, well, it starts at 2. But where does it stop decreasing? Well, this arrow keeps going, right? It keeps going to the right forever. So it's going to go to the right, and we saw that infinity. So decreasing for this example that we just made up is from 2 to infinity. Now increasing is from negative infinity to 2. Here's the first example. Looks like we have a V shape. Let's add on arrows on the end, students. We are going to fill out all of the characteristic, which is on the right side. Now, as you can see here, it's harder to see on my screen, but hopefully on your paper, it's a little bit clearer. As you can see, can you guys see that this right here is the x axis right here in the middle? Okay, so I'm gonna draw that out so we can count it. It's somehow that just wasn't very clear. All right, so the vertex is right here. That is 0, comma, negative 3. Okay, when x is 0, y is negative 3, so the vertex is 0, negative 3. Looks like we have 2 x-intercepts. One is over here, and one is over here. So, looks like they are negative 3, comma, 0, and 3, comma, 0. The domain is talking about all values of x. Students, the arrows on the ends here, that means they go left and right forever. We're going to write this 2 ways, all real numbers using the r, and the interval notation, which is from negative infinity to infinity. This right here is called the interval notation, okay? Interval notation. Now, we just got done defining the word increasing interval. Increasing interval is when we write small x, comma, big X, right? Larger X. So it increases when y goes up. Well, y goes up when we have a positive slope. Can you, students, see that this is a positive slope? So it starts increasing at this x location right here. That's the lowest point. So obviously there's nothing else lower than that. So that point for x is 0. Now where does it stop increasing? Arrow, meaning it goes up forever, indefinitely. So it like that, right? But how do we quantify if there's an arrow? We quantify it by using the symbol infinity. Again, that's why it's called increasing interval notation. We have to use it as 0, comma, infinity. So this right here is x1, comma, x2. It's a smaller x, comma, larger x. Rate of change, remember that is fancy for slope, right? So let's count. We're just going to count the slope really quickly. And usually when you count the students, just pick a nice point, okay? From here to here, it looks like rise over run. So rise is up, run is 1. Up 1, right 1. Now, but this absolute value symbol, this V shape also has the second line over here. So that's going to go what? Up 1, left 1. So on the right has a positive 1 slope. On the left has a negative 1 slope. So the rate of change for this is plus and minus 1. Or you can write negative 1, comma, positive 1. Okay. Minimum value. Minimum value is the lowest value. And we're going to use the y value. So the minimum, lowest value at negative 3. Axis of symmetry. Axis of symmetry is based on your definition is a line that divides the graph into exactly 2 equal halves. So that means here's the line right here. That is the axis of symmetry. And this line is called x equals to 0. And the reason it's called x equals to 0 is because it intersects the x-axis. So axis of symmetry is x equals to 0. Y-intercept looks like we intersect the y-axis at 0, 3. Yep, and that happened to be the vertex. And sometimes, yes, they can be the same answer. The range is all of the outputs, aka all of the y values, right, guys? Well, the smallest y value is -3. Oh, that does not look like a 3. Okay, -3. And again, this arrow means it goes up forever. When you say up forever, that means it's infinity above us. So the range, the smallest number is -3, and the largest is we don't know because it's infinity. So this is the interval notation. Now, we could also write, or when you write both ways, y is going to be bigger than or equal to -3. Decreasing interval notation. Decreasing interval, students, remember, decreasing, when we write it in interval notation, we want to write smaller x, larger x, right? So decreasing is when the y goes down. Y goes down means if we look at a line, there should be a negative slope. So another thing in years past, I said, can you slide down? Okay. Yes, wee. So if you can slide down, then that's decreasing. What is the smallest x? Well, again, this is going and going to the left forever. So that's going to be -infinity. Where does it stop? It has to stop when it is the lowest. So the lowest value x happens to be at 0 for this question. So decreasing interval, students, is from -infinity to 0. Now the vertex is usually, okay, again, I'm just going to give you a hint. The vertex is usually where the increasing and decreasing happens, or ends, I should say. Is this a 1-to-1? 1-to-1 first, you have to say, is it a function? Okay. It does pass this vertical line test, so it is a function. Now, but does it pass the horizontal line test? No. One horizontal line test intersects at 2 locations. So what this tells me is that one y value has 2 different x locations, x1 and x2. So that is not a 1-to-1. Even though it is a function, it's not a 1-to-1 function. Okay, students? Now, do we have a maximum value? A maximum value meaning that, hey, is there a highest value that we can pinpoint, we can locate? For this particular one, the answer is no. The reason we cannot find a highest of the highest value is because we have arrows. Arrows means they do go up forever. Because it goes up forever, we can't say which one is the highest. So maximum value, student, is NA or none. So example 2 gives us a different graph, and again, we're just going to fill out the main characteristics. We are going to add arrows and the ends. Now, this one doesn't have a vertex, so as definition, vertex is either the highest or the lowest. We don't have that, but we do have this thing called inflection point. So I'm going to cross it out and write inflection point. Inflection point, students, it's where usually it happens in a cubic, usually. It's where we have a graph that changes from opening upward, as you can see here, to opening downward, okay? So we have an inflection point here at -2, looks like that's a 3. So -2, 3, okay? X-intercept, definitely. X-intercept for this one, let's just make it nice and round it to -1. So that's going to be a -1, 0. The domain, again, with the arrows on the left, that means it goes left forever. Arrows on the right means it goes right forever. So that's going to be all reals. Now, and I do want you to write both notations, students, all real or from -infinity to infinity. So we want to know how to write it. This is, again, called interval notation, okay? Increasing interval. Increasing interval meaning that, hey, is there a, as we write it from small x to large x, okay? So small x value, larger x value. Is the y going up? Well, ask yourself, can I slide down the entire graph? Or can I hike up? So for this particular function, it's a sliding down kind of graph, right? It doesn't matter where we end up. Can you guys see that we can only slide down? If you can hike up, okay, hiking. So if you are hiking up, then that's when you know that we can say that it's an increasing notation. But if you can slide down, then that means it's a decreasing interval. So decreasing all over the entire graph. So that means the smallest x has to be negative infinity and the larger x has to be positive infinity. Rate of change only happens if we have a line or an absolute value function. So for this one, next year, you're going to learn what it is. But right now, we're going to say it varies. Minimum value. Minimum value, students, mean, hey, is there a smallest y value that we can pinpoint? And the answer is no. It's about putting arrows on these ends. So minimum value is NA, or you can write none. Axis of symmetry. Axis of symmetry is a line that divides the graph into perfect halves, and that's not possible. So for this one, we can say none or NA. Y-intercept. Yes, we do have one. Looks like, I'm going to approximate that about -5. So y-intercept is 0, -5. The range is listing out all the y values. The smallest y value is negative infinity, and the largest y value is positive infinity. So negative infinity to positive infinity, that's your interval notation. Or right now, we can also write all real numbers. Now, this happens to be decreasing the entire time, students, because we talked about how we can slide down, right, students? This, we can slide down. Whee! Yay! Okay, the entire function is going downward. So it's going downward over the entire domain. So negative infinity to infinity. Next, is it a one-to-one function? Okay, so to make sure it's one-to-one, you want to check to see if it's a function first. A function is, remember, every x value, we can only have one y. So you make your vertical line test, it can only intersect it once, which does check. Now, a one-to-one is a special function. So not only that it has to be a regular function, every y value, does it only have one x? And that is true. So because the horizontal line test only crosses over once. So this is a one-to-one. Yay! Maximum value is none or NA, because maximum is the highest value, and because of the arrows going upward, there is no such thing. All right, let's do this one by adding in arrows. So first thing is the vertex. So here's the highest point, and that is 2.5 and 6.25. Okay, so 2.5 comma 6.25. X-intercept, yep, we'd have 2 at 0 and at 5. So 0, 0 and 5, 0. The domain, remember there's arrows on the right, there's arrows on the left, and vice versa. So the domain is going to be all real numbers. And we also write it using interval notation, meaning that it goes from negative infinity to infinity. Increasing interval, of course, there is going to be one. Remember, this maximum point right here, students, is going to break up the increase, decrease. So increase when you're hiking up. Oh, so tired. Man, this is hard work. Whew. Yep, I'm hiking up on this one. Too much work. So this means, oh, that doesn't look like a hiking picture, but you know what I'm talking about. So this one is when I'm hiking up, super hard work, okay? I'm sweating, and I'm gonna stop hiking up here because that's the top of the mountain. I cannot hike anymore. So increasing, it's always the smallest x. The smallest x is gonna be negative infinity. The largest x that we can increase is gonna be at 2.5. Okay, we can't hike anymore once we're at the top of the mountain, so that's why it stops here at x equals 2.5. Now let's go straight to decreasing. Decreasing is on the other side. Decreasing is when y gets less and less. If it gets less and less, meaning that we can slide down. So that means it's going to be 2.5 all the way to infinity for the decreasing x locations, okay? Rate of change, we are going to say it varies for now because we are not going to learn the slope yet for anything except a line and the absolute value function. Minimum value, there is no minimum value. None or NA, okay? We do have a maximum value, student. It's at the very top here. So the maximum value is the y value, and that's usually the vertex y. So that's 6.25. 1 to 1, let's check to see if it's a function first. A function meaning that does it pass the vertical line test? Yes, it does, right? It doesn't matter how many vertical line tests we draw in, it only crosses over once. Now, does it cross over your horizontal line test? And the answer, I shouldn't say does it cross over, does it pass? So each horizontal line test we make, it's crossing over twice, so it does not pass the horizontal line test, so it's not going to be a 1 to 1. The range is a list of all of the y values. So because we are using arrows here, the largest y value we have is 6.25. Arrows mean it goes downward. So that means it's going to be y is less than or equal to 6.25. Now we can also write that as an interval notation. We can write negative infinity all the way to 6.25, my bad. All interval notations, can you guys see that we're always going to write small x comma larger x or small y comma larger y? Y-intercept, it happens to be the same as the x-intercept location of 0, 0. Yes, we do have one axis of symmetry. That is the h value of your vertex. So x equals 2.5. Here's example 4, and let's go and add the arrows again. Now for this one, as you can see, it's not a parabola and it's not a V shape, okay? It's a polynomial. So for this one, we are going to say the vertex is none because it's not the highest of the highest or the lowest of the lowest, so there's no vertex for the polynomial. Since we have arrows going up and arrows going down, indicate that there will be higher values or lower values. We do have a couple of x-intercept, 3 to be exact. So that's 1, so that's going to be a negative, this is -1 right here. So let's see. So each one is a 0.2, so 0.2, 0.4, 0.6, 0.8, and then -1. So negative 0.4, so negative 0.4 comma 0, that is the first x-intercept. The second one is right there at 1 comma 0, and the third, that's 1.2, 1.4. Let's just approximate that to 1.425, comma 1.425. I'm just guessing on that one, okay? And you can eyeball that too if you want. The domain, the arrows on the right and the arrow goes to the left. That means it's going to be all reals. Or write it in interval notation. All reals in interval notation is going to be negative infinity to infinity. The increasing is going to be difficult for this one, so I'm going to hold on to that and do that last. The rate of change, since it is not a line or an absolute value function, we are going to write varies for now. We can find the minimum value. So the minimum value is that guy right there. So what is that value? Let's guess that out too. Let's see, 0.2, 0.4, negative 0.6, negative 0.8. So let's say negative 0.9. Minimum value is negative 0.9, okay? Or you can write negative 0.9 if you want. Maximum value is this one right here. So 1's right here, 1.2, 1.4, 1.6. Let's round that to 1.6, okay? So maximum value is 1.6. Is it a 1 to 1? Definitely not. Look at this. It doesn't pass that horizontal line test. So that's like 3 places. So no. Again, I'm going to hold on the decreasing function. Let's talk about the range because that's easier. The arrow right here indicates it's going to go up and down forever, so the range is reals, or interval notation said we should write it from negative infinity to infinity. Now there is a y-intercept right there at 1. So y-intercept is 0, 1. Axis of symmetry, none. So because axis of symmetry, there's not a line that we can write that would make 2 equal parts. Now, increase and decrease. Remember, we talk about increases. Can I hike up somewhere? So the max and min is usually the break, okay? So over here, I could hike here, students. How do I? Okay, so this is hiking. So all this right here is hiking, and all this right here is hiking. So there are 2 increasing interval notation. The smallest x over here is negative infinity, and it takes a little break right here at that x value. And that x value, remember each box is a 0.2, so that's a 0.4. So that's 1 increasing interval. Then it picks up again right here. I'm going to show you. This is 1, this is 1.2. Let's say 1.3, okay, right here. So it picks up again at 1.3, and it increases again to infinity. Remember, we are using x values when we write increasing and decreasing interval, and there are 2 of them. Negative infinity to 0.4. We can technically spell out the word or, but in mathematics, students, let me write it right here. So in mathematics, you're going to see in our textbook, we don't have a textbook, they use this symbol U to represent or in math. Okay, this right here is really fancy in math, symbol for or. And so or 1.3 to infinity. There are 2 increasing infinity. Now there's 1 decreasing infinity. You know what? I do love to draw out my sliding. Okay. Whee! Yeah, I can slide down this entire way. Okay. So again, the max and min location usually breaks off the increase and decrease. Now that maximum location is again at an x value of 0.4. And this minimum is 1.3. So the decreasing is from 0.4, all the way to the x value of 1.3.